Hello, this is Anton from Canary Signal. In the previous video, we discussed why we chose Godot. Today, we are moving to practice and breaking down the technical implementation of our game's core mechanic, the 2D dynamic light system. The goal was clear: create total darkness, implement a directional flashlight with realistic shadows, and ensure walls physically block the light. Let's break down the implementation point by point. The foundation of the atmosphere isn't just the absence of light sources, but the forced darkening of the entire scene. In Godot 4, we use the canvas modulate node for width. It acts as a color multiplier for the entire canvas. We set the modulation color to pure black. Since any pixel color multiplied by 0 equals 0, we achieve absolute darkness. This allows us to hide unexplored areas without using complex fog of 4 systems. The player's light consists of two components, implemented via point light 2D nodes. The first component is the flashlight. For the texture, we use an image of light cone. In the settings, the option shadows is turned on so that light does not pass through obstacles. Direction control is implemented in the player script with a single line. The node simply rotates to follow the cursor. The second component is the ambient glow, or aura. This is a weak circular texture with a small radius centered on the character. It is necessary so the player can see their own hitbox and immediate surroundings, even if the flashlight is pointing in the opposite direction, or doesn't work. The most important aspect is the interaction of light with walls. To ensure object casts shadows, we use the occlusion layer in our tileset settings. Without this, light would simply pass through the wall sprites like X-rays. By drawing occlusion polygons on the wall tiles, we tell the engine which parts of the map are physically barriers for light rays. This creates realistic shadows behind pillars and corners, essential for the gameplay loop. Standard shadows in 2D can sometimes look too sharp or pixelated. To soften the image, we use a light duplication technique. Over the main shadow casting flashlight, we overlay a copy of it with lower intensity, energy, and shadows disabled. This creates a light bleed effect which slightly illuminates the shadows themselves. This ensures shadows aren't pitch black voids but retain some environmental detail. Additionally, using a gray floor color instead of black allows for correct color blending when light hits the ground. As a result, we achieved a performant lighting system that relies entirely on standard Godot 4 tools. In the next video, we will talk about our medical system. As you remember from our concept reveal, we are ditching the standard HP bar. We will show you how we implement a complex status-based system, where you have to treat specific injuries, like fractures and infections, instead of just refilling a health meter. If you want to see more behind the scenes content and daily updates, follow us on Telegram, Instagram, and TikTok. All links are in the description. This is Anton, Canary Signal. See you in the dark. And remember, we are grateful for your sacrifice.